Okay, this video is an introduction to exponents, or it's the introduction for IB. I'm assuming that you've seen exponents before, so hopefully this is good practice, and we're going to extend some of what you know and go a little bit deeper. I am making this video because they just took my second period to go get their class rings or be sold class rings, so I don't want you to fall behind. To begin with the exponent laws, I'm expecting that you know this, but the first one here would be a times m, a to the m times a to the n would be equal to a to the m plus n. If I have a to the m divided by a to the n, I'm going to subtract the exponents. If I have this a to the m and it's being raised to the n, this would be equal to a to the mn. You multiply, but you can even you could extend this out. This could also be written as a to the n raised to the mth. Okay, so those would all be equivalent. And what we'll see is sometimes we might have 4 to the x, and it might be helpful for us to recognize that this is 2 squared to the x, which is 2 to the 2x, which could also be written as 2 to the x squared. Okay, this is a little foreshadowing for what's coming later. So this property right here, all of these things are equivalent, and sometimes they may give you this, but it's easier or it's more necessary to put it in this form. The next exponent law that we want to look at is this. If I have a times b to the n, then I can say this is a to the n times b to the n. Now we'll see something like this. If they give me 10 to the x, I might need it in the form of, well, this is 2 times 5 that are both raised to the x. So it might be helpful for 2 to the 5th, I lied to you, 2 to the x times 5 to the x. So maybe put parentheses, that might make this look a little neater-ish. Okay, so something like that. Continuing, we have this a over b to the n. You would have a to the n over b to the n. This might be a case of, I might have something where I could divide it first and then raise it to a power. That might simplify my life. Anything, the next property here, anything, here it is, anything to the 0 power is equal to 1. If I have it a to the negative n, this is going to be 1 over a to the n. So if it's in the numerator, it moves to the denominator and we lose the negative. If it's, okay, I'm looking at this part here. If I have 1 over a to the negative n, it's in the denominator, it's going to move back to the numerator. And then, okay, if I have a to the m over n, this is like saying, well, it's the nth root of a to the m, or it could be the nth root of a raised to the nth power. If I saw something like, say, 64 to the 3/4 power, I'm more likely, I'm not gonna take I'm not gonna raise 64 to the 3rd power and then take its 4th root. I'm likely to do this, where I would say, okay, well, the 64, the 4th root, am I doing this backwards? Okay, let me try that again. Let's say if I have 64 to the 4/3, because 64 is 4 cubed to the 4/3. Okay, and then those power to a power, we now get 4 to the 4th, which is like 16 squared, which I have memorized, and that's 256. Okay, let's see. We have done the introduction. I'll keep going and make a second video.